Hey YouTube, how is it going? I hope all is well. Today we are going to look at doing the layout for this guy. This preamp, of course, is what I mean, but we are not, I can tell you right now, we are not going to be using this in the actual production product. So this layout that I'm going to show you is kind of moot at this point, but it will get me through this portion at least here. Maybe what I'll do is I'll use this as the basically my prototyping board, and then when it actually comes to building the real product, I'll go the route that I want to go. The reasons I'm not super duper happy with this is the way that it's laid out. These two tube sockets are clocked right now, so they're not in parallel with each other. Well, so they are in parallel with each other, or I guess perpendicular, depending on how you want to look at it. All I can tell you is that pins 1 and 9 are at the bottom here, and that means that the heaters have to go in from this angle here. I can't just run heaters right down the middle. And I would like to run the heaters down the center, so I don't have to have a run that goes down, around, and over again. Probably not incidental or problematic for me. I could just drill new holes and then reclock these. The way that this is laid out here with the turrets on the edge here, it does work really well for the layout that I'm doing, but I'm going to have to play around with it. So for now, I will use this and we'll make this work. But when it comes down to it, I can't say that this is actually going to be what I use in the production piece. So there's that. So let's go to the monitor over here and I'll show you what I have done. So this program that I'm using is DIY Layout Creator. It is a free software, and with free software, you know, you kind of sometimes get what you pay for. I like it because it does make nice looking stuff. You know, it works. It is a little clunky. There are some things to it that make you want to, you know, shoot yourself in the head sometimes. One thing that kills me right now is, I don't know if it's just because I'm running on Windows 10 or something, or if there's some little bug in the software, but let's say I make, you know, a couple moves here. Like one of the last 2 moves I did was I put these 2 wires in here, right? This is like the finishing, you know, part of the whole project, right? Well, if I were to hit Control Z right now, it would probably undo the last 2 moves. And let's see if that's the case. Oh wow, it only actually undid 1, I'll be danged. Maybe it's because it's where I saved it last, I don't know. But a lot of times it seems that if you do one thing and you don't like it and you hit Control Z, it'll undo the last 2 or 3 things that you did. Sometimes it's very, very frustrating. So this software is similar in some regards to Schemit here, where you can save favorites and all the, you know, the different symbols and parts and whatnot are under menuing. They're under menus in here. And the same thing, you know, you got building blocks, you got boards, connectivity. Some of this always makes sense. Connectivity would obviously be wires and other things that you would connect to. Electromechanical would be like switches and, you know, anything that's a connector of some sort like that. Guitar, you know, it's going to have, I don't know what the freeway 3x3 whatever is, but it shows pickups and stuff like that. And then you got some miscellaneous crap here. Probably don't really use that too often, but then the passive is where most of this stuff is going to come from. So you got your multi-section capacitor, you got pots, resistors, etc., etc. All this stuff is in these menus here, and then you can save them if you'd like by right-clicking on it. Let's see one that I haven't done yet. Let's just pick this one. So if you click on it, and then it's timid, like I said, it's a little troublesome sometimes. But if you right click on the part when it allows you to, it's not letting me do anything right now. So yeah, you can kind of see why it's a little bit frustrating sometimes. But in either case, you can select the part and then you can tell it to add to favorites. There's a couple other things that you can do too. So you can see here how I have the size of these resistors. It's not the right size, but it is a size. If you right click on it, you can go to edit selection. And then over here, if you click on these things here, it'll create a, what would you call it? Like a preset more or less that when you select those things over here, the next time you go to create that part, it will do it using those values. So you can see here, all I did was label these R1, 2, 3, 4, etc., etc., C1 through 7 or 8 or whatever the heck it is. I didn't bother putting the values yet because they all correspond magically with this guy right here. You have to imagine we're looking at this from the bottom, so the bottom up. So the low cut, it's kind of convenient how this little thing worked out. So I've got low cut, drive, which I normally call volume, and then I have volume, which I normally call on my amps master volume, and then the high cut. It's almost laid out exactly like my amps are, because I generally end up low cut first, then a volume, and then I have some sort of a master volume and then a high cut. My 18 watts laid out like that anyway, but I decided to go with volume here to be less, I guess I could put master volume, it doesn't really matter, but drive is drive, it's true what it is, so yada yada yada. The tonal aspect of it is on the outer edges. Again, not certain that this is exactly how it will work out, but I think this layout is going to work really, really well for what we got going on here. I was able to keep all the power stuff right up the middle here. For this particular one, I'm going to go with the Mojo Tone parts, mainly because they are just a little bit smaller in size. I was looking at like the F&T, I want to use 30 UF in this position, and I don't even think I put a value down here. No, I didn't even bother. I want to go with 30 UF or 47 UF, that would be nice, but they start getting a little bit too big, way too big. The F&Ts, the 47 UF is, interestingly enough, smaller than the 30 UF, but I wanted to go with something bigger than 22 UF. I wanted to make sure I had good filtering going on. So I decided I was going to go with 30 UF, and the only thing I could get in the size I wanted it, at the quality level that I was looking for, was the MOD brand. There's nothing wrong with them. I've said it in other videos before, just pick a company and run with it. It does not matter that much. Especially when I think you're looking at the power supply. I like the F&T because it is, I think, as good as it comes for that purpose. The MOD stuff is actually rated better at 105C, whereas the F&T is usually like 85 or 90 or something. I don't know, 85 or something like that. Whatever, standard stuff. But the MOD does rate out better, but that's beside the point. My whole thing where I'm going with that is that, you know, just pick a brand that you are happy with. If you want to spend the money on Jupiters, spend the monies on Jupiter. If you want to go with all Sozo stuff, go with all Sozo stuff. If you want to go with all F&T, Vishay, you know, Mallory, whatever it is, just pick one. It doesn't really matter. I can tell you that I am not a fan of the orange drop stuff. There's a reason for that. It's not that they sound bad. There are certainly ones that you want to, you know, stay away from. I can't remember if it's the 716 series or the 715 series, whatever. Because I don't use them. I can't recall off the top of my head, but I don't like them only because they are just ungodly huge. They're way too big for what they need to be. And, you know, I mean, come on, let's just be realistic. They're just, there's not that much of a difference in them to justify the cost of them. Some of them are a little egregious, but in either case, I like Sozo. I will probably use Sozo in this one, or I might even use some of the leftover Vishays that I've got, mainly because this is just a test platform right now. This is a prototype that you are watching me build here. Some of these don't mind. This guy here, it doesn't look like it would fit, and ordinarily it wouldn't, but this is actually a silver mica cap that I'm going to use in this position here, and it is significantly smaller than this here, so it should fit in this space that I got. But you can see how I was able to get everything to kind of line out almost exactly where it needed to go. I'm not a super duper fan of this whole run that I have to do here to get from the drive into the second stage. I guess I could have been a jerk and reversed this, but it just makes it a little more complicated because when you're looking at this, it's not reversed. So you're not going into valve 2B first, you're going into valve 2A first. So I kept it this way because this was the only one that kind of went in a direction I didn't care for. Yes, it would have been nice if this just ran straight down and went into there, but that would also then mean that this power has to be on this side, and it would reverse everything up here as well. So I kept it simple. It's the only one that does that, and yada yada yada. So we'll see how it goes. But it's kind of cool because I was able to keep the power in the middle. All the noisiest stuff is kind of all down in here, out of the way. The heaters are going to come into here. So I'll run something that goes into here, and they will twist out this direction, and then this one will twist out this direction. I will not actually be using these heaters right here, or these turrets right here. I just did that for visual, some place to lock it in place and let you know that it will be there. But the main B plus will come in here, and you can actually see that. You got R11, R12. Well, it makes sense here. You got R11, R12, etc., etc. So makes sense, right? So the B plus will come in here. This is the first dropping resistor, first node, decoupling cap, and then it goes into this next dropping resistor. I probably could have, I don't think I could fit both of these together. When I was looking at the specs on them, I believe they were I think it was 0.47 inches or something like that, which is just shy of a half an inch. Well, if you cut a half an inch in half, that is a quarter of an inch, and these things are 3/8 of an inch. So it's just over, that distance. So they might fit together, but I'm not 100% sure that they would. I don't think they would, because you'd be sticking over a quarter inch this way, and from this one you'd be sticking a quarter of an inch that way. So quarter and a quarter, that's half an inch. Yeah, so I have to split these by this one thing here. But I guess I could have been a jerk. I could have just removed this turret and then ran that all the way over there. But I'm going to have a jumper there. There it is. I decided I would jump this here as opposed to just running it all the way straight across. It probably is, probably doesn't matter either way, even if you were to just jump it all the way over there. All it was going to do is save me all these turrets over here. Big whoop. So I guess with this one here, no, I'd have to run a wire either way. So these are the cathodes, of course, for that second stage. These two on the outside here, and of course they're linked together because they do both go to ground. It just didn't appeal to me to run that all the way over to that point to get rid of that one wire. So I don't know, maybe I'll do that. Depends on, we'll see. We'll have to play around with that a little bit. Now, I do not have the switches in here, so these wires that kind of come in like this are irrelevant at this point right now, because by the time I put the switches in down here, I'm going to have a wire that has to unfortunately run all the way down and then all the way back again, which is unfortunate. Because if you think about it, you're going to have the input that comes in, and then it's going to have to jump all the way back around over to this point here to get straight to the output. It would be so amazing to have like a remote switch, and the only way around that is to use, something else that requires A, more power and current, and B, more complicated circuitry to make it work. So like a relay or some other sort of even, like a JFET type switch or something like that. That could be done. Is it a JFET? I don't know, whatever. You know what I mean. Like you could use another thing here to do a switch electronically, but again, it would require more crazy circuitry. So I'm going to go ye old analog and run a wire all the way down, and then it will have to go all the way back up to the output for the bypass side of things. There is that. But you can kind of see here what my mentality was with the whole idea behind this layout. It's just try to be as clean and tidy as you can and get things so they fall where they need to land. Luckily, it kind of just worked out that in this state here, without any kind of bypass switching or stuff like that, this would work just how it is. This will not be how it is. I need to put in the switches. So I just didn't bother with it because that's something else entirely. And again, I'm not even certain that this is the layout I'm going to go with. I might want to make it so that these turrets go on the outer edges, and then I'll have a row in the middle, because as you can see here, I've got probably 4 or 5 that I don't need out of all the, I can't recall how many are on here exactly. I think there's like, 1, 2, 3, 4, 5, 6, 4, 5, 6. There's 12, there's 24 turrets on this board, and I probably don't need half of them. So, or I might need just over half of them. But in either case, you can kind of see what the idea here was. So this video might end up being a little bit shorter, mainly because, you know, there's just really not much to go over. I implore you, if you know of another software, do let me know. I do, like I say, I do like DIY Layout Creator, especially given its price. It is free. They do have a thing on there where you can, you know, like tip them a coffee or give a PayPal like donation. I'll be honest in saying I haven't done it yet, and it's mainly because of the amount of energy and time it takes me to just do even this. Going through some of the little hiccups that it has, it makes you want to tear your head out or hair out, but so that makes it frustrating, just to say that in the very least. So let's just kind of recap a little bit on things here to get a little mileage out of this, because why not? I hope this kind of makes sense what you're seeing here and how it relates to this guy here. So as you can see, we have the input, and I did wire it just like you would see it here. So again, no switches on this one. I didn't bother putting the power supply into here because it doesn't matter. The power supply is a separate thing anyway. So you can just kind of get how it lays out. I got all those jumpers that you see here on V1. And then I've got, you know, the low cut. It gets kind of complicated with the low cut. You know, you got to be mindful of the different directions. I'm not even 100% sure this is right. This one could be wrong, actually. Ooh, no. Yeah, this is backwards. Whatever. There's those little things you can't always remember when you're looking at it. But, so yeah, in either case, yeah, it should be wired just like this one kind of is. But in either case, so this wire here, well, let's just freaking do it, I guess. Whatever. Boop. And then this guy will go here, and then this will go, and then this one will go there. Ta-da! All right, all done. Anyway, and I also still need to have this run to ground as well, because that does need to run to ground. So let's just go ahead and do that as well. So it kind of works out anyway, because it just kind of encapsulates everything right there, just like that. And ta-da. Or I could have also just made a jumper that went over to here, but this kind of just makes it easy. And then let's change the color of this, because why not? We're here, right? Bloop. As you can tell, I didn't quite finish this up all the way, but so there's all kinds of different ways you can do this stuff. Obviously, you're just trying to make it so it's got the cleanest, shortest runs you can possibly get. Maybe it would be shorter to go from here to there. Probably would be, to be honest, and I wouldn't have to have another jump. So let's just do that. I'm just going to get it done. There we go. And let's go over to here. Click. And then this guy is going to go there. And that's going to put it on top of everything, no doubt, because why wouldn't it? Yeah, it did put it on top. So what we're going to do is take this guy and go like that. There, now it's right. Ta-da. All right, so in either case, you kind of get the idea. You're just trying to make things as neat and tidy and clean as you possibly can. Sometimes it works out, sometimes it doesn't. But these are switched jacks, so this would do what it's supposed to do on the input side and mute it when it's not plugged in. I didn't bother muting the output jacks. I didn't bother with it. It probably doesn't matter either way, but you know what? Let's just do it because I can. So this would kind of go like that. And then you take this guy and change its color. Oh, see? This is what I'm talking about. It is just, you gotta be like spot the heck on, or it will not select what you thought. Very, very timid sometimes. And then here I am now. Yes, I know. It can be frustrating. I don't know if it's me, but whatever. All right, so let's talk about one other thing that's very important for you to think about when you plan ahead. I created this box around this here. It's just an 8x8 box. This is not the size of the box that will be used. I tried looking for a bunch of different sizes, and the only ones I could find that weren't just ginormous was, of course, by Hammond, and it was a 5.77 by 4.77 by 1.55, which basically means it's a 5 3/4 by 4 3/4 by 1.5 inch box, or internal dimension box. This turret board right here is 5 1/4 by 3, so it's 3 inches wide, 5 1/4 wide, which means I'll only have 1/4 of an inch on either side of the chassis or the box, which is about where this line is almost. These are 3/8 inch spacing, so it's almost about this width on either side that I'll have left. So this thing would just barely fit in it. These will basically be right over the top right here, because this board is 3 inches wide, and the little power module that would fit right back here, if it fits in there sideways, so if it goes in sideways, it would work, and I would be able to fit this to the very top edge of the chassis, and the little power board would fit at the other edge of the chassis. So this, as it sits, this will barely fit. Honestly, if I were to kind of cut this thing almost in half, I could probably make it work better, because that means these little guys here literally would be right over the top of everything, which in this case probably wouldn't bother things too much. But then I got to fit these guys in there too, so that means this guy can't be in the middle, so it has to be on the bottom or up at the very, very top in order for it to fit everything. And I'm not really into having the tubes literally stick out the top of the box, so this is going to try to be as low as we can, and these might even have to be up. So you can see how tight of a fit it will be. I can tell you right now that with this particular turret board and the way it's laid out, it will not work in the box that I have bought. So this will be built in a different box for the prototyping stage, where we can proof everything and find out a way to shrink it as much as possible. This is why I was talking about possibly going to PCB, because at least with the PCB, I can shrink all this stuff up dramatically and make it using the PCB pots that have the little standoff legs that come down. I think they make some that got like inch-long legs or longer even. I could literally wire it directly to the board and have this whole board and the tubes kind of drop in as one giant piece. So we'll have to see about that. We'll have to see. I gotta come up with a finished product first. You may also notice that when I'm moving around, or have been moving around, you don't hear any more squeaky squeaky. I got me a new chair and it doesn't squeak. Thank the Lord. It was bugging me. I don't know if it was bugging you, but it was certainly bugging me. But anyway, I squirreled a little bit there. So yeah, you really got to think ahead of time when you're making these things or designing these things, what you're actually going to use to put all this stuff in. I knew it was going to be challenging with this, whatever you want to call it, board I was going to use here for this. I just didn't know it was going to be as difficult as it was. So this board cannot be used in production for me, unfortunately. So there's that. I would like to use full-size pots, and I probably will with the 3/8 inch bushing. I don't like using those small little 10 mil, the little baby ones. I don't like those. So I'm going to try to use these here as best I can. These will fit within the chassis, and they will do very nice, I'm sure of it. So anyway, I just want to say thank you for listening to me ramble on as much as I have. I hope this kind of is clear. Again, just be mindful that this is untested at the moment. So even though this seems like it should work, it has not actually made any noise yet. I do want to say something that I know will be factual. This will not have as much grit as you think it will. So when we think of an amplifier that's got this kind of topology in it, let's go back to this thing here. This is essentially what a plexi has, right? So a plexi has one stage or two stages. It's got the high and the low input, or the normal and bright input, right? That goes into this orientation here, or this topology here. If I could get the words out right. Into this circuit here. But then that circuit goes into a phase inverter. The phase inverter is responsible for probably a lot, if not most, of the distortion in this circuit right here. Obviously, this tube here does not distort. Neither of those two in a plexi do, because those are the first stage. This one may break up as you start actually getting the volume or gain pot wound all the way up. And this one may start to actually distort before this one does. But I can guarantee you that the phase inverter is probably distorting long before this one even does. So in any master volume amp where the master volume is prior to the phase inverter, the gain that you do get obviously is coming all from the preamp, and you'll probably note that there aren't that many plexi style amps that don't have cascaded gain stages where they had a master volume in it. And the reason is there's not that much crunch in here. So this pedal, I am going to imagine, will be a fairly mild overdrive pedal. It's kind of another reason why I started with it first, is knowing that it will be probably the most low gain pedal of the ones I'm anticipating to make. Now, if that does not work for me, and I feel that, again, like I was mentioning, I'm not a fan of cathode followers. If that does not work for me, I will then cascade these two as a normal gain stage, which will then completely change this whole layout here, of course. But in either case, then I'll try that. If that doesn't work, then we're gonna have to split this guy and go something more normal. But my intention was to have kind of 3 levels of gain. One that kind of produces more of a mild crunch, but has kind of that AC30 / plexi kind of thing going for it. Another one that was more gainy, so you know, something like this, my little parallel triode into a cascaded pair. And then the one that kind of does the whole thing, which is to split this one for sure and have, you know, 3 other cascaded gain stages. So that's the idea, the plan, and the intention. Is just kind of go from mild to wild, I guess, if you want to call it that. But we don't know for sure if that's where it's going to go yet. So enough of all that bull crap. Play around with this, get this stuff here, get DIY Layout Creator and just play around with it. Scheme it, come up with some circuit, just find one, you know, open it up in another web page and then just copy and paste. It will really help you kind of get an understanding of what's going on as you actually lay it out yourself. Obviously, if you're already, you know, knowledgeable about this stuff, I'm just preaching to the choir. But for those of you that are new, this is a really good way to learn how to read a schematic, build a schematic, and understand where all, you know, how to get from this to this. Because if you can see this in your head, if you can literally see this in your brain, and you probably could by the time you actually finish it, then it really helps on getting this. Because you can literally just go, okay, I have this, I know it needs to go to that, etc., right? That's the big thing, is getting literally something that is linear put in your head to something that is non-linear, because this is non-linear. Parts do not go logically where they should. You know, sometimes there's a wire hiding behind things to connect them, but on here it doesn't look like that. It just, you know, to you that's what it looks like. And you can actually do a layout where it falls linear like this, where it almost kind of goes one-to-one, but it's very, very, very difficult to get it to fall in line the way you want it to, because you got to imagine these pots don't necessarily go in the order that you think they do. So if you recall here, it's low, then drive, high cut, and then volume. Well, in here I was able to get it so it was volume and then high cut. And I could just as probably easily go the other way with it and, you know, put the high cut first. Really wouldn't matter either way. I just flop that over that direction and then move this that direction. You can do that. But then I still got to run a wire somehow or another to this guy here and get it to that. So there's a ton of different ways you can do this. I'm just saying that depending on how you want to do it will change how your layout lands. So anyway, thank you so much. Take care. We'll see you in the next one.